Just along for the ride. All right, you want to start with number 1? Haley? Okay. So this is something I think you have to do it next year. Like there might be like a couple lessons, like not a lot, but you'll probably see it again. So do you remember like the slope formula, like y2 minus y1 over x2 minus x1? So the distance formula it uses those same things. It uses the y2 minus y1 and the x2 minus x1, but instead of putting like y2 minus y1 over x2 minus x1, you square them. You square each of them, and then you add it together. You add each one together, and then you take the square root of the whole thing. So I'm gonna set up number 2. So for number 2, remember x1 and y1, it's like the first x they give you, the first y they give you. That's x1, y1. x2, y2 is the second x they give you and the second y they give you. Does that make sense? Before we even like do anything else? Okay. So, and again, it doesn't really matter which one you put first, like the x2 and x1 or the y2 and the y1. You just have to square them both and then add it together and take the square root of the whole thing. So I'm going to do it like I'll do x2 minus x1, and I'm going to write it in here. So my x1 was 122, x2 is 106. So the first thing I have in there is 106 minus 122, and then squared. So those are the x's. I did the second x minus the first x squared. So now I have to do plus, and then the second y minus the first y squared. Remember, if you go 2 minus 1, he's got a picture of me and everything. Wow. Remember, Haley, if you go 2 minus 1 with the x's, then you have to go y2 minus 1 also with the y's. Okay, so since I did x2 minus x1, I have to do y2 minus y1. Thanks, Minna. So now I'm going to add y2 minus y1, which is 304 minus 367 squared. Okay, so that's what plugging everything in would look like. This is the distance formula. It's the x minus the x squared plus the y minus the y squared. You just have to make sure that you match them up. So we did 2 minus 1 with the x's, we did 2 minus 1 with the y's. Okay, so I'm going to subtract each and square it. (106 minus 122). We got 304 minus 367. So it should be something like this, Haley, now. Negative 16 squared plus negative 63 squared. Let me know, Haley, if you're with me or like if you got the same thing, if that makes sense. Or are you already done? Did you get the answer already? Usually what happens in class. I'm still working it out and you get the answer. Okay. What'd you get? What'd you get for the answer, Haley? Oh, you can see him. What's up, Zeus? Okay. So this is what I got next when I did negative 16 squared, I got 256. And then negative 63 squared, I can't remember what I got, something weird. And then you should end up, when you add those together, it should be 4225. And then remember, the last thing we have to do is take the square root of that. So we got a square root 4225, and then that should be our final answer. That's like the total distance. Let me know what you get. Hey, buddy. It's okay. Come sit down. There you go. Perfect. Okay, just do 1 and 4, Haley. Cross the rest of them off. Just do 1 and 4, and then just call it good for the ready. So Haley, cross off 3, 5, and 6. What's up? See the ball? See the ball? Look at your ball. Look get it. Good boy. Yes, one is 13. Good boy. Let me see that ball. Let me see that ball. Good boy. Can I see it again? Can I see the ball? Hey. Drop it. Drop it. Good boy. Okay. Get back. Get back. Hey, no. Get back. Get back. Sit down. Good boy. You ready? Oh. Crazy guy. Yeah. It should be the square root of 58. Whatever that is. So like what? It's okay, Zeus. It's just the wind. It's just the wind. Hey, it's just the wind. Should be the square root of 58. So somewhere between 7 and 8. Yeah, somewhere between 7 and 8. Yeah, 7.6. Perfect. If you think about it, Haley, the square root of 58, 7 times 7 is 49. And 8 times 8 is 64. So because it's between those two numbers, that means that the square root would have to be between 7 and 8. So like that's a way to guess or like estimate without a calculator. Does that make sense? Good boy. Good boy. Okay. Let's go to 7. Let's do 7 next. We'll do all the odds for the set. So 7, 9, 11. Okay. So I believe Let's do volume. Let's do volume first because volume's the easy one. So let me look it up to make sure. Okay, so I'm going to look up right now, Haley. Volume. So this is a pyramid. 7 is a pyramid. So I'm going to look up volume of a pyramid. Let's see. I don't like any of those ones. Okay, so it's out that. There we go. It's 1/3 the area of the base times the height. Okay, so remember 1/3 is the same as dividing by 3. So we basically take the area of the base. So for number 7, that would be 4 times 3. Area of the base. Multiply it by the height, so that's 2. So we got 4 times 3 times 2, and then we divide that by 3. So area of the base times the height, and then divide by 3. So I'm going to do that right here. Let me know what. Yes. And so since we're talking about volume, that's cubic feet. So like instead of square feet, like 8 feet squared, it's 8 feet cubed. Because these are 3-dimensional shapes. So it's to the 3rd power. There's a Math in the Garden video where I was talking about like cubic feet of dirt. Because when you're filling up a garden bed, it's like a 3-dimensional like prism. So you always use cubic feet when there's 3 dimensions. Okay, so that's the volume. Good? Ready for the surface area? Okay, so before we even start, for this one, for a pyramid, how many surfaces are there on the pyramid, Haley? How many surfaces do you see? Yep. There's 5 surfaces. So what's the area? The ones on the side are the weird ones. But what's the area of the bottom surface, Haley? What's the area of the bottom surface? The bottom of the pyramid, I guess I should say. It's a rectangle, remember? So remember, we're talking about area of that bottom rectangle. You got the dimensions right. 3 and 4 is the base and the height of the rectangle. So what would the area be then? Yes, 12. So the bottom's 12. So that's one surface. That's the easy one. So the bottom's 12. Okay, so now we have there's the front and the back. Do you see, Haley, how the front and the back of the pyramid are going to be the same? And then the left and the right are also going to be the same? So the thing about the front, though, is that it's tilted. So let me try to draw this. So to figure out the area of those triangles, we need that the area of a triangle, remember, is half of the base times height. Okay, so we need the base and we need the height of that triangle. But if you think about it, I'm trying to figure out how to draw this. So if you take this face out, this front triangle, to find the area of it, okay, this is surface area, we need the base and the height. Okay, the base we have, the base is 3. The problem though, the height of that triangle, the dotted line there that you can't really see in blue, it's slanted. It's like at an angle. So it's not this. It makes you think that 2, but it's not. So what we have to do, okay, now I'm going to try to draw this. This is going to get really weird. Okay. Tell me if that makes sense to you. So what the 2 really is, the 2 is like the overall height of the pyramid. So like from the very top straight down, like that line I just drew to the bottom of to the bottom base. Okay, but the height of this actual surface is like the slanted part. Does that make sense? So this is what I'm going to take now. What I'm going to do is I'm going to take that triangle out and I'm going to redraw it. Okay, but now the thing is here, so when I'm redrawing this triangle up here, the height of it's 2. The height of it is 2. It's too high. But if you look at this base of it, the base of it is actually half of this other side. So it's actually half of this 4. So the base of this triangle here that I drew in the middle of this, that it's like a slice of it kind of, is actually, it's like 2 by 2. And we're going to find the diagonal slanted height. So this triangle up here, this question mark, is now the actual, that slanted height of that face, of that surface, which is what we need to find the area of the front and the back. Does that make sense? Okay, so again, I know it's weird. It's hard to explain. So again, just going back to what we're trying to do here. We're trying to find the area of this surface right now. Just if you just think of a pyramid, the surface. So we need the base of that surface, which is 3. We have it. But then we need the height of that surface. So the height of this actual surface is technically, it's like slanted. So what we have to do is we have to think about this right triangle. If we dropped a line straight down from the top, hit the bottom at 90 and went across, that's going to make a right triangle. The height is 2. The base is 2. And so whatever that slanted height is, that's the hypotenuse. So we need to do the Pythagorean theorem, 2 squared plus 2 squared equals x squared to get that slanted height. Okay, so I got the square root of 8. There's a video on the YouTube channel. It's somebody else explaining it. It's way better than this because they have like a computer program where they can like draw that triangle and like take it out and spin it around and stuff. But basically the height now of this face, what we just figured out, the height of this face is the square root of 8. So that original triangle, this is the original face. We knew the base was 3, but we didn't know what the height was. Now we know it's the square root of 8. So the area of this front face, we just do 1/2 of 3 times the square root of 8. And that's going to be the front and the back of the pyramid. So what I'm doing over here, is I'm making notes to myself of what the area of each surface is. Okay, so I had the bottom was 12. Now I know that the front and the back, I don't know exactly what it is, but it's going to be 1/2 times 3 times the square root of 8. 1/2 the base times the height. That's going to be the front and the back. So there's actually going to be 2 of those when I go to add it up at the end. Does that part make sense? Even if you don't know how we got the square root of 8, does it make sense now? Kind of what we're... Okay, so now we need the left and the right. Okay, so to get this is the right side. To get the right side, we know the base of that triangle is 4. But again, the height of that triangle on the right is slanted. So we know the base of it's 4, but the height is slanted. So we're going to have to draw like another imaginary right triangle from the top of the pyramid down to the bottom and then over to that point. It's kind of like a slice of the pyramid, so that we could do the Pythagorean theorem to get that slanted height. So now, again, my drawings are terrible, but now we kind of are dealing with this. Okay, so this one, again, it's too high because that's the height of the pyramid. So from the middle straight down to the middle, it should be here, actually, going over. Okay, I'm going to shade this one in now that we're dealing with. This is getting confusing. And again, you have to watch the video. But now we're looking at this triangle, okay, or this slice. Okay, so it goes across, the bottom goes across this way. The diagonal part, the hypotenuse of it, is the slanted height that we're looking for. So we need to find that hypotenuse. And then the height of this shaded in right triangle is the 2. So I'm going to take that right triangle out, put it over here, and tell me now if this makes sense to you. So now this shaded in triangle, I drew it over here. It's kind of smaller, but again, it's 2 feet high. 2 feet high. But then across now, this distance here, the bottom of this shaded in triangle is only half, exactly half of this whole side. So instead of a 3, it's a 1.5. It's half of this. So now to get that slanted height that we're looking for, we got to do 1.5 squared plus 2 squared equals question mark squared. So now it's going to be weird. 1.5 squared plus 2 squared. 6.25 square root of 6.25. So remember I see what you did. I know why you got 7. 1.5. Yeah, do it again. You did 1.5 times 2, and that would give you 3. Then 2 squared would be 4. 3 plus 4 is 7. But remember, it's 1.5 squared. So 1.5 times itself is actually that if you do 1.5 squared. So it's actually that plus 4. And then don't forget, you got to take the square root at the end. Remember, so 1.5 squared plus 2 squared equals x squared. Try it again. There you go, 2.5 exactly. You were close. I see what you did. You were really close. So now that, remember that 2.5, that was the height of the left and right surfaces of the pyramid. So now that means for our left and right, to get the area of those faces, it's going to be 1/2 times the base times the height, which we just figured out was 2.5. So what that gave us there, that 2.5, where that goes, that told us that for the left and right faces or surfaces of the pyramid, that 2.5 was the slanted height of those sides of those surfaces. And we needed that because the area of those surfaces, triangles, 1/2 base times height. So now we know that the left and the right is 1/2 times 4, that's the base, times height, which is 2.5. So we got the bottom is 12. Jeez. We got the bottom is 12. We got the front and back is 1/2 times 3 times the square root of 8. Then we got the left and right, 1/2 times 4 times 2.5. Okay, so now we got to do the multiplication for the front and back and left and right. And remember, we got to multiply. There's 2 of each of these. So it's front and back. We do all this times 2. Left and right, do all this times 2. Then we add that plus the 12. So let's do it together and let's see what we get here. Does that make sense? What steps you need to do, Haley, on the calculator before we start? Let me know if you want me to repeat those steps, Haley, before we start doing them. So front and back is 1/2 times 3 times square root of 8, yes. And then whatever you get, you double it because the front and the back. Exactly. So I'm going to do that with you right now. So I got I got 4.2 when I did that. And remember, it's on your calculator, it's on your phone, it's kind of hard to press in. So like on my phone, I did 0.5 times 3 equals. But then you have to do times, but then you have to hit 8 and then the square root button. And it's going to give you the square root of 8, and then you hit equals, and that should be your final answer. So it's honestly way easier to do it in Desmos. Because in Desmos, watch, I'll type it into Desmos on my phone and show you that on my screen. On Desmos, what the hell is going on? Oh, when you multiply it by 2, right? Yeah. After you double it, it should be 8.28. I was just showing you, I was just doing the one. Yeah, so I like Desmos. I'm just showing you how to type it in, Haley. But that's right. 8.48. So now we got to do left and right. Hair is messed up. Do you remember what that one was? Okay, so I think left and right was 1/2 times 4 times 2.5. One half times 4 times 2.5. So that would be 5, then you double it. And it should be 10. Let me know what you get for the left and right. Shoot. Try something. Oh, you're right. Oh, something's wrong with my chat. I don't know why it's doing this. Message retract. Dude, what the heck? It says unable to connect to chat. Please try again later. Interesting. My chat sucks. Yes, 30 point, yes. I don't know why it's doing that. Okay, so 11. So I'm going to look up, let's do volume first. I'm going to look up the volume formula for a cone. So this is a cone. So volume of a cone it's basically the volume of a cylinder divided by 3. So if you think about it, if you think about like a soda can, and you kind of imagine like being able to turn like cones upside down, you could kind of like, if you arranged them right, you could kind of fit 3 of them. So a cone is like, that's why you divide by 3. A cone is like 1/3 of a cylinder, if that makes sense. So this is the volume formula. Pi r squared times h divided by 3. Radius is 5. The height is 15. So it should be, let's see. That's 25 times 15. Divided by 3. So let me know what you get, Haley, but it should be something like 125 pi for volume, pi r squared. So pi times 5 squared times the height, which is 15. Yeah. And then divided by 3. And again, it's cubic feet. Yeah, feet.